Hello once again, class, and welcome to another mock lecture. When we left off, we were constructing the unit circle, and today we're going to use it to evaluate sine and cosine, as well as talk a little bit about the wrapping function. So some quick recap right off the bat here. Here's the unit circle, right? We used it to essentially form graphs of sine and cosine, which I've drawn here in the same graph. And one of the things we noticed is that sine and cosine are just a pi/2 shift, away from each other. Now you might look at the unit circle and you might think to yourself, there's no way I can memorize this, right? It's way too much. Luckily for you guys, I have a quick way to remember some of the key angle measurements, the key outputs for specific angle measurements pertaining to quadrant one. So you'll notice that here I've got, the quadrant one key radian measurements, 0, pi/6, pi/4, pi/3, pi/2. And then I've also got cosine and sine, and I'm just going to list some of the values here. Now, here's the quick way to do this. Put everything over 2. Literally every spot is going to have some numerator divided by 2, okay? And then I'm also going to make every numerator be some kind of a square root. So, and this part is you just fill this out, right? If you're trying to remember some key outputs on the unit circle, square root something over 2 for every single output in quadrant 1. Now, what you're going to do for cosine is count down from 4, and those go in the blank spaces of the square root. So square root of 4 over 2, square root of 3 over 2, so on and so forth. For sine, you're going to count up from 0. So square root 0 over 2, square root 1 over 2, so on and so forth. Now, these are basically the outputs, right? For sine and cosine at 0, pi/6, pi/4, pi/3, and pi/2, but they're obviously unsimplified. So at this point, you just need to simplify them, right? Square root of 0 is just 0. So this whole thing is just 0. 0 divided by 2 is 0. The square root of 1 is just 1. So these two things just become 1/2, right? Square root of 2 over 2 and square root of 3 over 2, those actually can't be simplified. Those are already as simplified as we can make them. So those are just what they are. And then finally, at cosine of 0 and sine of pi/2, we have the square root 4, which is just 2. So we really have 2 over 2, which is 1. And there you go, right? There's the quadrant 1 outputs for sine and cosine on the unit circle. Okay, so now that we know that, let's get to doing some examples here. Obviously, today we're mostly going to be concerned about evaluating angle measurements inside the sine of the cosine function that's outside of the unit circle's very obvious measurements. So things that are either less than -2 pi or things that are greater than 2 pi. Our first example is going to be the sine of 7 pi over 3. And there are a few approaches, right, for how to do this. And I tend to use some kind of combination of different approaches. But the first one that I think that we should consider is using a mixed number, right? Or as I call it here, using a proper fraction. So I think about, obviously the unit circle is cyclical. It starts repeating itself as you go past 2 pi, or as you go maybe to the left part of the graph past 0. But essentially, what I want to do here is turn 7 pi over 3 into some kind of a mixed number so that it's very obvious to know that we're past 2 pi in this case. 7/3 as a proper fraction is written as 2 1/3. So we can think about this as on the unit circle, we're going 2 pi, which is just coincident with 0, or coterminal with 0 is probably the better way to say that. But then we're going an additional pi over 3. Okay, so then here's my making it coterminal with 2 pi is 0. And then I go an additional pi over 3, and look at that. We're still in quadrant 1. In fact, we're at pi over 3. So we're finding the coterminal angle. In this particular case, it's pi over 3. So the output for the y-coordinate, which is what sine is on the unit circle, sine's definition is the y-coordinate on the unit circle, it's the square root of 3 over 2. So we're done. Square root of 3 over 2. The second thing you can do is you can use what's called a reference angle. And a reference angle is actually that table that I just showed you guys, where we were counting down from square root of 4 over 2 all the way to square root of 0 over 2. That is quadrant 1, and typically reference angles are always quadrant 1 angles. Here's a very kind of formal definition of what a reference angle is, but I think it's enough to get us by in this lesson. But it's a quadrant 1 angle, or an acute angle, that can be used to represent any of the other angles. For example, right, anything that has a denominator of 3, so any number pi over 3, is going to end up being coterminal with one of these 4 points on the unit circle. Unless it's unsimplified, right? I mean, you could have 6 pi over 3. Okay, well, that's obviously this point. That's 2 pi. So, but anything that is simplified as much as it can be and has a denominator of 3 is going to show up in one of these 4 places. But here's the thing to notice. All of these points are exactly the same value if you take their absolute value, right? They're all 1/2 for the x coordinate, and they're all square root of 3 over 2 for the y coordinate, right? Obviously, in this case, we're talking about sine. So our answer is going to be square root of 3 over 2. We just need to figure out, is it going to be positive or negative? So what I think about is, well, what quadrant is 7 pi over 3 inside of, right? I know that it's bigger than 2 pi, because 6 pi over 3 is 2 pi. I also know that it's less than 5 pi over 2, which is coterminal with pi over 2, which places it in quadrant 1. Okay, so then the next thing I have to think about, well, in quadrant 1, is the sine function positive or negative? Well, since it's a y coordinate in quadrant 1, it's positive. So then I know that it's going to be the square root of 3 over 2. Okay? And in fact, maybe I can just extend this idea a little bit further. The next slide is about counting out some stuff. But, even if I said, let's say we want to evaluate the sine of 103 pi over 3. Like, I automatically know my answer is going to be square root 3 over 2 because it's got a pi over 3 as its reference angle. I just need to figure out, is it positive or negative, in this specific case. So the third way, right, that we're going to do this is we're going to count out the number of pi over 3s. So I'm just going to count 7 pi over 3s. So here's 1, right? There's 1 pi over 3. Here's 2, 3, 4, 5, 6, 7, right? And so we're in quadrant 2. We're in quadrant 1. And so we get square root 3 over 2. Okay, obviously I used the same example for every single one of these things. But what I find myself doing is kind of utilizing different facets of these kind of 3 approaches. I was going to say 3 main approaches, but these are just the things that I tend to use when I'm solving these things. You might have a better methodology, and that's fantastic. Okay, here's another one. Cosine of negative 19 pi over 4. So now that we have these kind of basic methodologies in place for how to solve this thing, let's go through a different example. This one's negative. Okay, well, for me, it's pi over 4. So the reference angle is pi over 4, which means our answer is going to be square root 2 over 2. In fact, whether this was sine or cosine, the answer is going to be some kind of plus or minus square root 2 over 2. We just need to figure out what quadrant we're in so that we can figure out, is cosine positive or negative in that specific quadrant. All right, so I've got negative 19/4 pi as a proper fraction. That's negative 4 3/4, right? Or as a mixed number. 4 times 4 is 16, add 3, so that gets you to the 19/4, although in this case you're subtracting since it's negative. So negative 19 pi over 4 is the same as negative 4 3/4. So what I would do then is I would go to 4 pi, right? Or in this case, negative 4 pi. So I'm going clockwise in this particular case. And then I'm just going to count out 3 pi over 4s. So 1, 2, 3. So it puts me in quadrant 3, which means that this must be negative square root 2 over 2, since both sine and cosine are actually negative in quadrant 3. Okay? Here are a bunch more. And I invite you to pause the video at this point and pick one of them. Pick one of these things to do, and then pause the video, and then when we come back, we'll go through them all. All right, welcome back. Hopefully you paused the video and did at least one of these things. Let's see how you did. So first thing is, here's all the answers. 0, 1/2, 0 again. 7 pi, right? Negative 7 pi. Any odd-numbered pi is always going to land you here on the unit circle. And any even-numbered pi is always going to land you here. So since this is an odd-numbered pi, I knew that we would end over here. But that really only matters for cosine, because the sine of any whole-numbered pi is always going to be 0. And that's what I have here. The sine of a pi is equal to 0. And this is true for any a in the integers. So pick any integer. That amount of pi's is always going to be 0 for sine. It'll oscillate between it'll oscillate between -1 and 1 for cosine. But for sine, it's the y-coordinate. And when you're on the x-axis, the y-coordinate is 0. For 5, For 4, rather, the sine of negative 11 pi over 6, I saw that as being almost negative 2 pi. So if we subtract 1 more pi over 6, then we would be at negative 2 pi. So a negative 11 pi over 6 is pi over 6 more than negative 2 pi. Since we're going in a clockwise direction because it's negative, that actually puts us in quadrant 1. And the y coordinate for the pi over 6 reference angle is 1/2. So 1/2 is the answer there. And then finally, with number 5, the cosine 25 pi over 2. Okay, similar with 3, actually. Any pi over 2 is always going to get you either here or here, right? Which for cosine means it's 0 no matter what. For sine, it means it's going to oscillate between positive 1 up here and negative 1. But since we're talking about the cosine, I just put 0. We do end up being, I believe it's here is where we end up being, because 24 pi over 2 would get you at 12 pi. That's here. Then you go an additional pi over 2. So yeah, you're going to end up here. But again, for cosine, it's going to be 0, whether it was 25 pi over 2 or 27 pi over 2, which would have put us down here. The cosine of that would have been 0. So I put cosine of a pi over 2, or a over 2 pi, is equal to 0, again, for all integers a. But that's only true for cosine. So now we're going to transition to the wrapping function. No, not this wrapping function. The wrapping function. Like we're literally wrapping stuff around the unit circle. Right? That's what the wrapping function actually is. Now, here's the definition. W of theta is equal to cosine of theta, sine of theta. So here's the first interesting thing. The output of this function is actually an ordered pair. So the way that I think about it is the input of this function is some angle measurement, and then the output is some point that's on the unit circle. So if I were to plug in pi over 2 as this angle measurement, right, then it would give me back 1 and 0. Right? In fact, it would give you the whole point, 1, 0. No, it wouldn't. It would give you the point, oh man. It would give you 0 and 1. Yep, 0, 1. That's a 0 and a 1. Make sure that you know this is a 0 and this is a 1 for pi over 2. I should have just switched it, right? I should have just made it like 0 as the theta measurement. Oh well, I'll have to fix this somehow in post-production. Or maybe I'll just leave it in because mistakes happen in math. And what do you do for mistakes? You learn from them. You become a better person, better individual in general. Now, by the way, this wrapping function thing, like this is my definition of the wrapping function. That's fine. W of theta is equal to the cosine theta sine of theta. Technically speaking, the wrapping function comes from literally taking some kind of like metaphorical string, hypothetical string, maybe that's the right word, and wrapping it around the unit circle. So you've got a circle centered at the origin, its radius is 1, you got some string, we're going to put the end of it at 1, 0, and then we're going to take s length of it and wrap it around the unit circle here, and then we're going to say w of s is equal to xy, right? So this is the point xy right here. So really, it's an arc length that you're plugging into the unit circle, or that you're plugging into the wrapping function here. But here's the thing, it's a unit circle, right? I hear you saying, isn't it a unit circle? And I would say, well, yeah, which means that the arc length, which is radius times pi, on a unit circle, the radius is just 1. So s is theta, and so that's why I'm going to just say s can be theta. And since we're on the unit circle, we also know the x-coordinate's cosine and the y-coordinate's sine. So let's just go with this definition. Okay, so here we go. W of theta is equal to cosine theta sine theta. And using it is really easy. It's just the same as evaluating specific values of sine and cosine using the unit circle, except now you're evaluating both functions. So if I had w of 16 pi over 3, automatically I think of the reference angle, pi over 3, for which I know at pi over 3, cosine is going to be 1/2 and sine is going to be square root 3 over 2. We just need to figure out where are we on the unit circle? What quadrant are we in? And so for here, I just did, let's turn it into a proper fraction. 16 pi over 3 is the same as 5 and 1/3 pi. So here's 1 pi, here's 2 pi, here's 4 pi's, here's 5 pi. Then I'm going to go an additional pi over 3. And that gets us to negative 1/2 and negative square root 3 over 2 since we're in quadrant 3. So the answer is negative 1/2 and negative square root 3 over 2. Example 7. Let's say we have w of negative 777 pi. Don't be intimidated. It's an odd numbered pi, which means that it's got to be here. Got to be coincident with pi. It's coterminal with pi, which means that this point right here is negative 1, 0. So that's the output, right? Cosine of negative 777 pi is negative 1. The sine of negative 777 pi, that's 0. All right. So hopefully you guys found that helpful. If you have any suggestions, leave them in the comments. Thanks a ton for watching, and I'll see you in the next one.